Hi, I wanted to show you how I did this complex numbers quiz 4 because some of the things are rather complicated. So when you are supposed to do something like this that says you have, so it says z is equal to, I'm just writing this down on my iPad and I'll share it. So z is equal to -6 minus 5i. The formula that we are supposed to use to do this is, let me show this. Okay, the formula that we're supposed to use this is the inverse tangent of the imaginary part over the real part. And so then for this one, it's going to be the inverse tangent of 5/6 because that would simplify. But then this is going to give a positive value. So let me come back here because it says it's in degrees. So we're going to make sure that mode is in degrees. And you'll notice that the first answer it's going to give us when we do this is it's not in degrees. It's going to be in radians. So I'm starting out with decimals here. So I'm going to go into here. So we're going to do the inverse tangent of 5/6. And then we're going to get a positive value. This is defaults to radians. We need to change it to degrees. Now, so we have this 39.806 is what I'm going to write down. So 39.806. Oops, 6 degrees. Okay, so then the problem with this is this, if we were to graph it, it would be in the third quadrant because it would be back 6 and down 5. So this is going to be -6 minus 5i. Obviously, that is not this, right? So we want to get back to there, and it would be like over like 39 is like up here, 39 degrees is up here. We want this one directly back from there. So we are going to take that 39 and we are going to subtract 180 from it because that's the same as pi. That puts it directly across the graph from that. So we are going to do that 39.806 subtract, and so we get -140 point, I think we just rounded to the 10th, so 0.2. So 140, -140.2. So coming back to this one, it's going to be, -140.2. So checking it. Yay. So that's probably the hardest thing is when it's in a different quadrant. Make sure that you're going to either add or subtract 180 or pi. Then this one in polar form, I need to figure out what you would multiply by to get to this thing. Switched over to a different app. So we have this, we want this in polar. What we're going to want to do is figure out something that we could factor out of this thing that would make it so it's something on the unit circle. Because when it asks for exact, it's asking for something on the unit circle. In fact, let me show you what I mean, another extra thing that I mean with this. Actually, I'll just show it to you because it's very handy. You see lots of things coming up. I forgot I was moving my screen. Okay, so if we had the sine of theta, cosine of theta, tangent of theta of 30 degrees, 45 degrees, or 60 degrees, which is the same thing as pi sixths, pi fourths, and pi thirds, then the values that these would be goes like this. This is a really cool pattern. You ready for it? It goes 1, 2, 3, 3, 2, 1, 3, 1, 3. And everything that's not 1 goes underneath a square root. Then everything in sine and cosine goes over 2. This is the part that's really going to help us, but let me just figure out the last thing. The tangent of 30 goes over 3. So when we are looking at these values, notice that the values of sine and cosine are either 1/2 square root of 2 over 2 or square root of 3 over 2. So when we are going to, what we're going to do is we're going to factor something out of this thing that will leave some of those values in place of it. So remember that the value that goes in this part is the cosine, and then this is the sine. I should put theta there. Okay. So what could you multiply or factor out so that you would have, and it looks to me, and I see that this is 15, and that is a multiple, like it is the same thing as 5 times by 3. I can see that that's a multiple of 3 right here. So that's going to be 5 times by 3, which means that it's going to be from here, because that's going to be the square root of 3 over 2. So 2 things I want to do. One thing is I want to factor something out so that what's left is going to be a 1/2 here. And what's going to be left is going to be a square root of 3 over 2 there. And I got that from this green stuff that I highlighted. They both still need to be negative for the sake of keeping it in the right spot. So what would come out of there? In other words, if I had, basically what I want is 1/2 times by what is going to give us 5 square roots of 5. So, and again, that what is just simple algebra. So if we just multiply both sides by 2, we'd get it. So that thing that we want on the outside is going to be 10 square roots of 5. So if we factor out 10 square roots of 5 right here, then this was really in that form. But now to find the actual theta, because we said that this was the sine and the cosine, but to find the actual theta, it's going to be some multiple of that where it's, since these are both negatives, where it's in the third quadrant, because the x's and the y's, if that was a point, looks like a face, that's in that third quadrant, because we would go back and down, and it would be equivalent to 60. So it's actually not going to be back too far. It's going to be down further, where this distance right here is negative 1/2, and technically it's going to be negative 5 square roots of 5, and then this would be the negative square root of 3 over 2. And that one on the unit circle, the one that matches that is the one, because this angle right here, because it goes across from there, that's 60 degrees. So this is 60 degrees more than 180. So 180 plus 60 is 240. So that's going to be 240, puts us in the right thing. So the correct answer is going to be 10 square roots of 5, and then cosine of 240 plus I sine of 240. I was about to type it in, but then I looked at the directions and it said that it was supposed to be in radians. So now we need to know what is that in radians. And you can look on your unit circle if you have a unit circle, and I can send it to you. I can put it, in fact, I will put it in the comments with this thing. So this is a unit circle, and the radians that go with that are, so 240, notice that 240 goes right here with 4 pi thirds, square roots of 5, then cosine of 4 pi thirds plus I sine of 4 pi thirds. Now, before I move on from there, I wanted to share this and this format with you, because this picture that I have here, this table, with the accompanying unit circle is so helpful. And I actually have another video that I'm going to put in here with this link that's going to show how to use that. But that is the correct answer right there. You can see when I come back here, I typed it wrong because I forgot the 10 on there. So look up here, I forgot the 10 right there. So that's the only thing I did when I typed that the second time. This is the third time I've tried this problem. It's real. All right. Next one, the complex number has a magnitude of 12 and an angle of 45. We need to write this in rectangular form. I love these because we're going to take that magnitude on the outside and we're going to multiply it by the cosine of 45 plus I sine of 45. Looking at here, that's this one. And if we look up at our table, the cosine of 45 takes us to the square root of 2 over 2. And the cosine and sine of 45 takes us to the square root of 2 over 2. So then that means we're going to have 12 times the square root of 2 over 2 plus I. square root of 2 over 2. And if I distribute this 12 into those, it's going to be 6 square roots of 2 plus 6i square roots of 2. And that's it. That's our answer. So 6 square roots of 2 plus 6i square roots of 2. Okay. And then the absolute value of this is just the square root of both of those things. So this is one thing I think was kind of funny that you could do. If you just look at 4 squared is 16, and then 8 squared is 64, and they accept it. Haha. And then they'll see like how we answer this question because they just simply add them. And then this in radians, find the angle in radians that make this part of the complex plane. This is similar to the first one that we did, but the good news with that is it is still in that first quadrant, so it's pretty easy. So our imaginary part is 5, our real part is 6. It's in radians, so we go into Desmos and we can do the inverse tangent. So to the power of -1 is how I'm typing it. You can come down here and type this thing, but I can't see that, so I'm doing this. Of 5 over 6, and it looks like it is in radians, and I think you can put it in terms, oh my gosh. So you're supposed to round it to the nearest thousandth. So I'm going to come into here, paste it to the nearest 10,000th, and then edit. So it's going to be 5. There we go. Nice. Okay, so hopefully that helped you. You learned from my mistakes because I made silly mistakes, but that's pretty tough stuff and I wanted to show you how to do it. So good luck.